Okay, guys, welcome to 1108. And what we're going to do today is we're going to talk about how do we calculate how to dilute a solution. So if we start with a lot of times in a lab, you'll have a container and it has a known concentration. So it's it's kind of like, have you ever used the drink concentrates like Mio or the Gatorade concentrate? And you take your glass of water and you put a few drops of the concentrate in, and then it makes something that is pleasant for you to drink. A few drops in a glass of water makes the correct concentration for drinking. But you started off with something that was much more concentrated. We do that in chemistry all the time. And this would be common to do even if you just worked at a corporation, you were maybe in the factory, and you were working with anything that had a chemical application that had solutions. So this is a really important skill for you to have. The way that we can calculate dilutions, there's kind of two parts to this. You can calculate the volume that you're going to need, and then you have to calculate, okay, how do I mix it? So the formula that we're going to use is your initial molarity, and we almost always use molarity here, times the initial volume. And when we say the initial volume, we're talking about the volume of the concentrated solution. So for example, that would be your Gatorade concentrate or your Mio concentrate. That's going to equal your final molarity times your final volume. The way we write this in shorthand is M1 V1 equals M2 V2. Now, what would be your, let's do a sample one if you were doing that drink. So let's say a glass of water holds 200 mils. 200 mils of water. And let's say you're going to add to your glass of water 1 mil of your drink concentrate or your Mio. And let's say it gives you an actual chemical concentration. It wouldn't, but let's say it says this is 5 molar. Well, if you want to find the mathematical concentration of the glass of water that you're drinking, you would take 500 or 5 times 1, so that would be 5 equals M2 times 200. Now you'll notice I didn't convert to liters. If you have the same thing on both sides, you can get away with not converting to liters. So as long as I have mils on this side and mils on this side. Now be careful. One of the common mistakes is you'll take 200 divided by 5. That's not right. So you have to divide both sides to get the variable by itself. So you're going to take 5 divided by 200, and that glass of water that you're drinking, so your molarity is 0.025, and this is what you're drinking. You can see I started out with something that was very concentrated. It had a 5 molar concentration, but by the time I diluted it into 200 mils of water, I was drinking 0.025 molarity. All right, let's look at now something that is not drinkable, and that would be hydrochloric acid. So here, describe how to prepare 1 liter of 0.646 molar hydrochloric solution, starting with 20 molar hydrochloric. Well, right away, this is 20 molar, and this is 0.646. So that tells you that I'm going to have to take this really concentrated hydrochloric acid and dilute it to form 0.646 molar. My equation is M1 V1 equals M2 V2. So I need M1, I need V1, I need M2, and I need V2. So your initial concentration needs to be this 20 molar, and your final concentration needs to be 0.646. Now, that's one of the things I want to point out. We're diluting something. When you dilute it, you make it weaker, like we did up here with our drink concentrate. So I'm going from a 20 molar solution down, and I want to make 0.646. How much do I want to make? I want to make 1 liter of this stuff. So my answer here, my 1 liter, goes here. So this volume is your total volume. You need to understand that your final volume here is your total volume. So that means I need to figure out how much of this I'm going to need. So now I plug my variables in. I have 20 times my volume of my concentrate equals 0.646 times 1. And when I solve for my initial volume, I get 0.032, and this is going to be in liters. This side was in liters, so this is going to be in liters. It doesn't tell me how to prepare it. What this volume means, this means, and if I convert that to mils, then I need to start with 32 mils of concentrated acid. So if I need to use 32 mils of concentrated acid and I want my final volume to be 1 liter, so this would be 0.032 liters. How am I going to make that? Well, I'm going to put 0.032 mils, or I'm sorry, 0.032 liters into a 1 liter container, and then I'm going to fill it up to the 1 liter mark. So this means that I need to use 32 mils of concentrate, and I'm going to want to add to that 968 mils of water. So when you're diluting something, you're adding water to it. So I have to take my concentrate and then I add water until I get this final volume of 1 liter. So again, let me point this out. My concentrations, this is always going to be more concentrated and this is always going to be less because we're diluting it. These volumes, this is the total volume of my solution. This is the volume of my concentrate. So it is vital that you understand what these values mean. Okay, so here's a practice problem. Go ahead and pause the video and see how you do. And when you come back, we will take a crack at it. Okay, the question says, describe how you would prepare 250 mils of a 0.45 molar potassium hydroxide solution, starting with 8.4 molar potassium hydroxide. I always start with the formula, M2V2. So I have M1, V1, M2, V2. All right, I have 2 concentrations. I have 0.450 and I have 8.4. This is the more concentrated. This is what I'm going to use to prepare. Here's the 0.45 molar. Now, it's a describe how you would prepare question. So describe how you would prepare 250 mils of a 0.450 molar solution. So I want my total final volume to be 250 mils. So what I'm solving for is how much of this am I going to use, and then I'm going to add water to that. I'm going to have 8.4 times the volume of my concentrate. Maybe we should put a VC there, equals 0.45 times 250. If I want to put that in liters, I can do 0.250. When I solve for my volume of my concentrate, I get 0.013 liters or 13 milliliters. But I want my final volume to be 250 milliliters. So this is my concentrate, and then I need to add to that water. Well, how much water am I going to want to add to this in order to get it up to 250? If I subtract the 2, I see that I need to add 237 mils of water, and that's our dilution. You put these 13 mils into a container, and then you add water to it to dilute it to get it to this concentration. All right, I hope you got that one right. We're going to do some practice problems in class. Thanks for watching.